Okay, this time we're going to prove that the sum of the squares, right, which is 1 squared plus 2 squared plus 3 squared, where the nth term is n squared, right, that the sum of the first n squares could be represented by the formula n times n plus 1 times 2n plus 1 over 6. So this is the formula for Sn. Right, what's the first step? Prove it works for n equals 1. So prove that if I plug in n equals 1 into that formula, into this formula right here, that I get 1 squared, which is 1. So that'll be 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6, which is 1 times 2 times 3 over 6, which is 1. And if you add up the first term here, it's 1. So that checks. Okay. So that's, again, that to me, if I'm doing these, I would like to make that your first step. Your second step is write down sk plus ak plus 1 equals sk plus 1. Right. Your third step is we need to generate all these things, sk, ak plus 1, sk plus 1, so that we can substitute. So in this case, what is sk? Right. If this is Sn, if this is Sn, then put a k here. So that'll be k times k plus 1 times 2k plus 1 over 6. Okay, next we need ak plus 1. How do I find ak plus 1 if ak is n squared? What is ak plus 1? Say again? Put in a k plus 1. K plus 1 squared, right? Not k squared plus 1. It's k plus 1 squared, right? Replace the n with a k plus 1. And then the last one we need is sk plus 1. How will I find that? Here, 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 right? So that'll be k plus 1 times k plus 1 plus 1 times 2k plus 1 plus 1 divided by 6. And that can be simplified. That is k plus 1 times k plus 2 times 2k plus 2 plus 1, 2k plus 3 over 6. Okay, that was the step 3, right? Make all these things so that you can come back over here and substitute for sk, ak plus 1, yeah. 2 times k plus 1 is 2k plus 2 plus 1 is 2k plus 3. Right. All right, so now let's substitute here. sk, k, k times k plus 1 times 2k plus 1 divided by 6 plus ak plus 1, that's the next one, k plus 1 squared equals k plus 1 times k plus 2 times 2k plus 3 divided by 6. That's what we don't know. That's what we're trying to show is true. Okay, what do you think would be a good first step? Okay, by doing what? Multiply by 6. So let me multiply here by 6, and here by 6, and here by 6. Remember, every term. Don't forget a term. And then this cancels these two denominators. It cancels here and here. And so now we've got k times k plus 1 times 2k plus 1 plus 6 times k plus 1 squared equals k plus 1 times k plus 2 times 2k plus 3. Okay, any brilliant ideas now? You could just do a brute force method and start multiplying everything you can. Or you could notice that every one of these terms has a factor of what? It's got a factor of k plus 1, right? K plus 1 squared, k plus 1. How about let's do this. Let's divide everything by k plus 1. All right, that cancels this. It cancels one of these, not both, and it cancels this. So now we've got k times 2k plus 1 plus 6 times k plus 1 equals k plus 2 times 2k plus 3. Again, we need to make the left look like the right, or the right look like the left, or somewhere meet in the middle. How about let's start with a little distributive going on the left. 2k squared, that's not mine, is it? Plus k, plus 6k plus 6, which is 2k squared plus 7k plus 6. Okay, so now we still need to make this look like this. Well, again, you could factor it, or you could FOIL the right side. If you don't want to factor this, you don't have to. You just have to make them look the same. So why don't we instead FOIL that? Right, that'll be 2k squared plus 3k plus 4k plus 6, which is 2k squared plus 7k plus 6. And those are the same. So we showed that by assuming the formula worked for sk, it also works for sk plus 1. Therefore, Sn works for all n.